The torque produced by the force F is equals to 2I plus 4K minus 3J Newton at a point R is equals to 3I plus 2J plus 3K meter about the origin is the cross product is of the vector R and F. So torque is equals to the cross product is of R and F, which is equals to, we can use the determinant for I, J, and K components, and we can write the components of all the R's, which is 3, 2, and 3 again. But don't be confused here. You can rearrange the force as force is equals to 2I minus 3J plus 4K Newton. Just you can rearrange the force like that. You can interchange the places of K and J here. Don't be confused. So just we can write like 2 minus 3 and plus 4 here. So then we have the 3 components of the torque, which is torque is equals to the I component is, the J component is, and the K component is. Then if you want to find the I components, you can hide the column under the I. So I is equals to always J cross K. This is from the clockwise system, and the reverse is also the negative. So J cross K means 2 times 4 is 8 minus of 3 times minus 3, which is minus 9. And the J term is, we can cover the J column. Then J is equals to, we know that it is K cross I. So K cross I is 3 times 2, which is 6, minus 3 times 4, which is 12. Then from K, just we can cover the K column. Then K is equal to I cross J from the clockwise system. So then 3 times minus 3 is minus 9, minus of 2 times 2 is, which is 4. Then finally we have that torque is equals to 8 minus of minus 9 is plus 17I, 6 minus 12 is minus 6J, and minus 9 minus 4 is minus 13K. So this is the final answer. So the answer from the given alternative is D. So this question requires which one of the following is correct in a clockwise system. Clockwise system is the system which we use to determine especially the cross products of the basic unit vectors in Cartesian coordinate system. We use the I unit vector to indicate the x-axis, and we use J unit vector to indicate the y-axis, and we use the unit vector K to indicate the z-axis of the Cartesian coordinate system. So I, J, K are the basic unit vectors in Cartesian coordinate system. So which one of the following alternative is correct in a clockwise system? In a clockwise system, we know that I cross J is directly K unit vector, and J cross K is I, J cross K is I, and K cross I is J. K cross I is equals to J directly. And the reverse is also negative. You know, the reverse of them is, that means J cross I is minus K, and K cross J is minus I, and I cross K is minus J. So among the given alternative, the only alternative which fulfill the clockwise system is alternative A, J cross K is I. J cross K is I. by using this. So A is the only correct answer. The answer is A. But don't be confused here. Alternative C also true, that is J dot J is also 1, but this system is not the clockwise system. So for what values of A, vector A and vector B are orthogonal to each other? So we know that from orthogonality test, if two vectors A and B are orthogonal or perpendicular to each other, then the scalar product of the two vectors is 0. So then A dot B is AX BX plus AY BY plus AZ BZ. So A times 2A plus minus 2 times A plus 1 times minus 4. So this is equals to 2A square minus twice of A. This is minus 4. So this must be 0. So we have a quadratic equation with 2A square minus 2A minus 4 is equal to 0 is quadratic. So then we can use the quadratic formula. I can use quadratic formula by substituting let A is equals to x, then 2x square minus 2x minus 4 is equals to 0 here. From the basic quadratic formula, x square plus bx plus c is equals to 0. This is quadratic equation. Then from the formula, x is equals to minus b plus or minus square root of b square minus 4ac divided by 2a. So then from our equation, a is equals to 2, b is equals to minus 2, and c is equals to minus 4. So this is equals to minus of minus 2 plus or minus, our b value is minus 2, which is minus 2 square, minus 4 times a is 2, c is minus 4, and the radical divided by 2 times a is 2. So this is equals to 2 plus or minus, and 2 plus or minus, and the radical of this is 4 minus of minus 4 is also here, so this become positive. So this is 32 and this is 4, altogether 36 divided by 4. So this indicates that 2 plus or minus 6 over 4. Therefore we have two value, which is 2 plus 6 over 4, which is 8 over 4 is 2, and the other answer is 2 minus 6 over 4, which is minus 4 over 4 is equals to negative 1. So the values of a must be, just we have substituted x with a, then the values of a must be 2 and negative 1. So the correct answer is C. So the unit vectors r, which is along the direction of 2r1 minus 3r2 minus 5r3 is r. This is r1, r2 and r3 vectors. Then the unit vector of this resultant vector. So before going to find the unit vector along the direction of r, we have to find the vector r. Vector r is the resultant vector, which is 2r1 minus 3r2 minus 5r3. So this is equal to 2 times vector 1 or r1, 3i minus 2j plus k minus 3 into 2i minus 4j minus 3 k minus 5 into minus I plus 2j plus 2k. So this is equals to 6I minus 4j plus 2k. This is minus 6I plus 12j plus 9k. This is plus 5I minus 10j minus 10k. So collect the like terms. That means we can collect the I terms, the j terms, and the k terms together. I terms are 6, here also negative 6, and also we have 5 here. So 6 minus 6 plus 5, and the j terms are, or the j component is minus 4 plus 12 and minus 10. So minus 4 plus 12 minus 10 are the j components, and the k terms are here 2 plus 9 and minus 10. So 2 plus 9 minus 10. So this is equals to 5I minus 2j plus k. So this gives us 5, this is minus 2, and this gives us 1. So this is the resultant vector r. So unit vector r is vector r divided by magnitude of vector r, which is the vector r divided by magnitude of vector r is 5 square 25, minus 2 square is 4, and 1 square is 1. So this gives us under radical of 30. So unit vector r is 1 over radical 30 into 5I minus 2j plus k. So this is the final answer, which is C. Alternative C is the correct answer. Given three vectors r1, r2, and r3, then what is the magnitude of the resultants of the three vectors? That means r1 plus r2 and r3 magnitude. So let's assume vector r is the resultant of the sum of all the three vectors. So, and if r is the resultant of vectors r, that is r1 plus r2 plus r3, then what is the magnitude of these resultants from the sum of the vectors? So this is r1 plus r2 plus r3. We have three vectors, r1, r2, and r3. So r1 is 3I minus 2j plus k. r2 is 2I minus 4j minus 3k, and r3 is minus I plus 2j plus 2k. So then we can collect this the like term together. So that is the component I, the component j, and the component is k of these three vectors. Components I are 3 plus 2 minus 1, and the j components are minus 2, minus 4, and plus 2, and the k terms are 1, minus 3, plus 2. So this gives us 3 plus 2, which is 5, minus 1 is 4i. This is minus 4j, and this one is 1 minus 3 is minus 2, plus 2 is 0, which is 0k. So that is the resultant vector r is 4i minus 4j. The magnitude of vector r is equals to under radical of 4 square plus minus 4 square, which is square root of 32. This means that square root of 16 times 2 or into radical 2. So the correct answer is 4 into radical 2, which is C. If C is the vector, which is the cross product of the vector A and B, then C is perpendicular to both vector A and vector B. Then the unit vector C is perpendicular to both vector A and B. That means C is the vector which is perpendicular to the plane containing both vector A and B, and the unit vector of C is perpendicular also for vector A and B. So we can find this unit vector C, which is perpendicular to A and B vectors. So vector C is the cross product of vector A and vector B. So then we can use directly the determinant forms ijk, and this is components of vector A and these are the components of vector B. C is the vectors with the 3 components of the cross products of them, all of them. So as before, to get I, we covered these columns. We covered the columns under the I, and I is equals to J cross K. We know that. So J cross K is 2 times 1, which is 2 minus 3 times 2, or 2 times 3, which is equal to 6. And then we cover J. J is equal to K cross I. We know that. That is 2 times 2 is 4, and 2 times 1 is 2. 2. And then we cover also here the K terms, and K is I cross J. That is 2 times 3 is 6, and 2 times 2 is 4. So this is equals to, this is directly equal to 2 minus 6 is minus 4i. 4 minus 2 is plus 2j. This one is also plus 2k. This is vector C. So then unit vector C is equal to the vector C divided by magnitude of vector C, which is minus 4i plus 2j plus 2k, divided by the magnitude of vector C is minus 4 square plus 2 square plus 2 square again, equal to this is 16 plus 4 plus 4, which is 24, and the radical of 24 into minus 4i plus 2j plus 2k. But still we can simplify this. 24 is equals to 4 times 6, so we can say it is 1 over, and the radical of 4 times 6 is 2 into radical 6, and also we can take 2 common out is as minus 2i plus j plus k unit vectors. So these 2 cancels, and the unit vector C, the final answer, which is equals to 1 over radical 6 into minus 2i, sorry, here is 2, minus 2i plus j plus k is the final answer. So the answer, alternative A, is the correct answer. So clockwise system is the system which helps us to find the cross products of the unit vector in a Cartesian coordinate system, the basic unit vector. So I cross j is k, and the reverse is negative, and j cross k is I, and then reverse is the negative I, and k cross I is j, and the reverse is the negative. So then we can see that k cross I is also j, it is correct, and I cross j is also then minus of j cross I. This is the cross product of the vector is not commutative, so this is also I cross k is j, it is correct, but I cross I is 0, not 1. This means that we can see I cross I means magnitude of I times magnitude of I sine of the angle between I, but I is on the x-axis, this I is also on the x-axis, so the angle between them theta is 0 degree, so that is magnitude of I is 1 times magnitude of I is also 1 and sine of 0 degree, this is immediately gives us 0. That means the cross product is of two collinear vectors is directly 0. So the answer is B. That is, B is not correct in a clockwise system. So three forces acting on a single object is F1, F2 and F3. F1 has xy components, if this is x-axis and this one is y-axis. So F2 is along the negative y-axis and F3 is along the positive x-axis. So we can say that F1 is equals to minus 3i plus j. F2 is only along the j, that is minus 3 j, and F3 is only along the x-axis, which is 2 units among the I. The vector which indicates the net force acting on the object is F net is equals to the vector sum of the all forces F2 plus F3 acting on these objects. So this is equals to minus 3i plus j minus 3j plus 2i. So we collect the I terms, that is minus 3 plus 2i, and the j terms are 1 plus minus 3, which is j terms. So then this is equals to minus I minus 2j minus I minus 2j is the vector which indicates the net forces acting on the objects. So the answer is on alternative A. So which one is correct? We have four alternatives from this question number 9. So which alternative is correct? For any vector A, the components of this vector, which is along the x-axis, is greater than the magnitude of vector A. But it is impossible because we have the magnitude of vector A is always greater than the magnitude of its components. So this is not correct, completely wrong. B alternative says for any vectors A and B, that means for any non-zero vectors A and B, magnitude of A plus B is greater than magnitude of A. But this is not always true. It can be magnitude of A plus B can be less than even the magnitude of the vector A or magnitude of vector B, it can. So this is not always true. Alternative C says for any non-zero vectors A and B, A minus B is equal to B minus A, but this is completely wrong because the subtraction of vector is not commutative. So they are not equal, but we can say this is minus of B minus A. We can say it is the negative of B minus A. But when we come to the alternative D, for any three non-coplanar vectors A, B and C, then A plus B plus C is different from 0. This is always true, because just I want to tell you here 3 things about how the vectors add together and gives us null vectors. So if vectors are collinear, the minimum number of vectors required to get the null vector is only 2. So the minimum required vector is 2 and above. So assume we have 2 vectors A and B. If A and B are collinear, they are either opposite or parallel. To get the null vectors, A and B must be equal and opposite of each other. That means A plus B can give us 0 if they are equal and opposite. So the minimum number of vectors required for a collinear vector is 2 and above. But if the vectors are coplanar, that means the vectors are laying on the same plane but not necessarily on the same line, or not necessarily be collinear. Assume that we have 3 vectors A, B and C. A, B and C are not necessarily to be collinear, but they are coplanar. They are laying on the same plane. Then to get the null vectors, the number of vectors required is 3. We cannot get the null vectors by adding A and B, because A and B are coplanar. Still, this is not 0. This is the resultant vector, or the sum of the vector A and B. But what if I add the vector C like this? So I get the closed loop. That means we end up from where we have started, this point. A plus B plus C is 0. So if the vectors are coplanar, the minimum number of vectors required to get the null vector is 3 and above. 3 and above. We have to have 3 and above vectors to get the null vectors by adding the coplanar vectors. But if the vectors are not necessarily coplanar, the minimum number of vectors required to get the null vector is 4 and above. So we have to have 4 vectors if the vectors are not coplanar. So we can have 4 vectors A, B and C. Assume that we have 4 vectors, vector A, vector B, vector C and vector D. Then vector A can be laying on this plane like this, and vector B can be like this laying, but vector C is not coplanar with them. Let's assume that vector C is standing like this. Vector C is standing upward directly like this. So still I cannot get a 0 resultant, or the null vector. So to get the null vector, I have to add another non-coplanar vectors with A and B, which must be gives me 0. That means if I end up from where I have started. So the number of vectors required to get null vectors for non-coplanar vector is 4. So then we can conclude that the only correct alternative is alternative D. 3 non-coplanar vectors added together and they cannot give us 0. They not gives us the null vectors, or cannot be a null vector. So the minimum vector required is 4. These are the 3 vectors. They are not coplanar, so we cannot get the null vectors by adding them if they are not coplanar. So the required, or the minimum number of vector required is 4. So the given vectors are 3, but they are not always 0. This is the correct answer. So the answer for this question is D. So the vector product is of 2 non-collinear vectors A and B is A perpendicular to the plane formed by vector A and B. This is true if C is a vector formed by the cross product is of A and B are non-collinear, then C is always perpendicular to the plane which is containing vector A and B. So this means that if vector A is like this and vector B is like this, if they are forming the plane or parallelogram like this, then vector C, which is formed by A cross B, is perpendicular to both vector A and vector B. So C is perpendicular to this plane which is formed by the two vectors A and B. So A is still true. A is true. B says on the plane formed by A and B, but it is completely wrong. The vectors formed by the cross product is, or the vectors produced by the cross product is of non-collinear vectors A and B cannot be on this plane. It cannot be on the plane, or it cannot be less on this plane. So B is completely false. C must be 0. This is only true if the vectors are collinear, but if the vectors are non-collinear, we cannot have 0. So it is scalar. This is completely wrong because the vector product is of two vectors cannot be scalar. It's always vector. So the only true or the correct alternative is alternative A is the correct one. That means the vector product is of two non-collinear vector A and B is perpendicular to the plane formed by vector A and B.